AP Statistics, we have arrived at Unit 7. Okay, so we are going to talk about what Unit 7 entails, and you're just going to love it. This actually is a very important unit because all of our units coming up are kind of going to hinge on this idea of a sampling distribution because of the fact that we have to meet certain conditions in order to use the normal curve as a tool for our probability. So keep that in mind as we work through this stuff. All right, so we're going to start out first with just some basic definitions, and I'm going to explain to you in very general terms what I mean by sampling distributions. Well, as the name implies, distributions. That means we're going to create a graph of data. All right, and sampling means we're going to sample from a population. So let's talk about this. We've got a population distribution. So when I talk about population, that means everything or everyone in that population. I'm talking about the entire thing. So you're envisioning basically a graph of every possible data point that can be plotted individually to create the population distribution. Now, use a little common sense here. In reality, are we ever going to have every single piece of data within a certain population? Probably not. So we need a way of estimating that. Okay, so now let's talk about a distribution of a sample. All this is, it's just data that we collect in a single sample. So you're just going to envision a graph of just a sample from the population. All right, now that is different than a sampling distribution. Notice the use of the words here. Distribution of a sample versus a sampling distribution. A sampling distribution itself means that we have every possible sample of the same size, and we use N to represent that, from the population, and then those samples become all of our data. So in other words, this time you're going to envision a graph of repeated sampling, and that is going to create its own distribution. So when we talk about sampling, we need to know why we want to do this at all. Well, here's the deal. If I just look at one individual, for instance, let's say I want to compare or look at the distribution of heights among seniors in high school, okay? So let's look at that. So let's say I grab one kid who happens to be on the basketball team, and this kid is 6 feet 5 inches tall. Is that going to be representative of the population of all seniors? No, it isn't. So looking at one individual does not help me draw a conclusion about the entire population. But if I take a sample of lots of kids and I ensure that it's random and therefore representative and unbiased, I can then start to picture what would be on average the height of seniors. So averages and proportions are going to be less variable, and of course they're going to create a more normal distribution so that I can use the normal curve to find probabilities, et cetera, et cetera. So individual observations aren't usually helpful to us. All right, now you do need to understand moving forward, when we talk about sampling distributions, we are going to look at categorical data, which means just counts. So we're counting out of a population how many fit into a certain category. But we're also going to visit quantitative data. So those will be explored more thoroughly in other videos, but I do need you to understand that we're going to kind of branch off within sampling distributions. We're going to be talking about categorical data and quantitative data. So the things that will change are how we discover what the standard deviation, is for certain values, and also some of the notation that we use will be different. Okay, so I want to I just want to give you kind of a visual of this. I want you to picture a population. Okay, picture a population. And from that, we are going to have an average, or a measure of center, if you will. So we will have an average or a measure of center, or depending on what we're talking about, categorical or quantitative. It could be an average of something, it could be a proportion of something that represents the population. All right, and the parameter is going to be that center, okay? So this is called a population parameter. So if I'm talking about the height of seniors in high school, well, the population parameter then would be the height, the average height of all of them. And so when I take a sample from my population, it's going to be a smaller grouping, okay? And it's going to have a value that I can calculate because it's a smaller sample. So I can calculate everybody's height, and that can be my sample average. And that is called a sample statistic. And we've talked about these words before. Okay, so a population parameter versus a sample statistic. So the sample statistic actually is something we can calculate because we're taking a smaller group from the population. So it's something we can calculate, and if we do that over and over again, if we take more and more samples, I can create a distribution of all of these sample statistics, and it can represent a value that may or may not be able to be found, which would be the population parameter. So if you take sampling over and over and over again, you're not going to get the same sample every time. We call that sampling variability. It's normal because it creates our distribution. Okay, there's nothing wrong with it. All right, so when we're thinking about a sampling distribution, so let's explore this idea further of the difference between a distribution of a sample and a sampling distribution. If I were just going to graph this one sample, that's a distribution of a sample. But if I take multiple samples, in fact, if I take all of the samples from the population, all of the different samples. Let's say I'm taking a sample of 5, okay? And let's go back to that height idea. So these are high school seniors, high school senior heights, okay? And I have no idea how many high school seniors there are in this world, or in this nation or whatever. But let's just, for the sake of argument, pretend that it's not very big, okay? Let's just say it's like 1 million. I'm sure it's way more than that. Okay, so let's say we have 1 million people. So we are going to take sample sizes of 5. The sampling distribution, can I spell? The sampling distribution would take every sample, every unique sample of 5 that is possible among those 1 million high school students or high school seniors, and it would create a distribution from that. Is that going to be possible with us? Absolutely not. That's why we have sampling. So if we take multiple samples of 5, I can still create a graph, and I can still use it to make inference about the population. So that's why we sample, because the population is sometimes overwhelming, so we're never going to get all of those values.